well, we can go ahead and at least get started with introductions in case we have a couple more people coming in. So thank you guys for joining. This is our first in our series of ARA Alumni lectures. So we're going to bring in some of our really awesome alumni who are doing things at tons of different companies, schools. And today we have two people who are going to grad school currently. So we have Christopher Simpson, who's a PhD student at Alabama, and then Chase Trautman, who's a master's student at Purdue. And they can both talk a little bit. It's really nice. We have the PhD and the master side, and we have at Alabama and away from Alabama. So they can share those perspectives with you and share how they decided what they wanted to do. And hopefully you guys will have some questions to ask them about their paths and, kind of get you prepared for your future. So yeah, I mean, we can go ahead and get started. Chris, do you want to start us off?
Sure, I can do that. I've got my presentation here. Did this share the screen? Okay.
Yeah.
All right. Let's do that quick. So Jane tells me Jane, thanks for the introduction, by the way. I hope everyone's doing well. I think we're kind of blessed to have a Zoom capability. And Jane tells me that we have an equal opportunity audience here. We have a bunch of freshmen and sophomores as well as juniors and seniors. I don't know if that's the case, but I kind of made this a little broad so that I wasn't going to put the freshmen and the sophomores to sleep, because I know they may not be completely sure of whether they want to do grad school yet or not. So that's why it's graduate and post-undergrad, or in other words, how do I make more money doing what I like? So just real quick, this is 5 slides, 7 slides. Make more money, you're gonna have to pay me to go here. Graduate school, and at least what's your mentality going into graduate school? And since I'm the old fart in the room, having graduated with my bachelor's in 2016, there's a slide for history of the rocket program. So wherever you're at right now, there's 3 things that you can do right now that'll help make you more money in the future, at the very least, a better prospect for internship, career, or graduate school. Go make a website. I got my advisor's website up there that you can go peruse. He's the example that I try to aspire to. I got mine as well. And use your hobbies. All of you are in rocketry, so you already got a good start. If you have something that you used to do before college, this particularly for the freshmen, or that you do now while you're in college, maybe you did photography. You could go do high-speed photography of when you go do your level 1 launch, or maybe you do athletics, and part of athletics is reviewing film and being professional, or at the very least. So maybe you could go, work on professional presentations and how to give a professional presentation and do a little series on that. But anyways, the big point to take away from that is that you do something that's not a slog. You go have your little hobby, you have a little fun, and you work on your technical skills while doing that. And the important part of that is you get feedback. For me, I have an easy route through my advisor, my PhD advisor, Dr. O'Neill. I go do something. I'm like, hey, what do you think? Says, oh, well, okay, you need to work on your analysis here because you didn't, do X, Y, or Z. All right. Just something simple that helps improve your skills. Now, if you're going to graduate school, and you've already decided you're going to graduate school, get it paid for. There's the best way to go to grad school, or excuse me, the best way to go to grad school is for free. I think an even better route is to have independent funding. So in some cases, when you pick your advisor may be doing some research where he has slots that he can put graduate students in, or may be able to support you via a graduate teaching assistantship. But there are scholarships out there that allow you to be a little independent. So like SMART, which I'm doing right now. So I'm literally being paid to go to school for 4 years, and in return, my butt gets shipped out to China Lake, which is the Naval Air Weapons Center for Weapons Development. Naval Air Warfare Center for Weapons Development. There we go. NACWD. Anyways, I got to go out there for 4 years. because I got paid to go to school, and then I'll get paid to work there. So guaranteed job, and I get paid. Not bad. There's some other scholarships without commitment, so you don't have to ship out to the middle of the desert and go work for 4 years for the Navy, like Alabama Space Grant here, or your NASA Graduate Research, or NSF, or IndySeg. IndySeg's primarily for minority applicants or underprivileged applicants in STEM. Yeah. And graduate school, so your mentality going into graduate school, I'm sorry, it's still a job. You know, like whatever you may believe about graduate school, the only difference about graduate school being a job is that you are managing yourself. You are now self-employed. You know, when you go into graduate school, one of the things you want to think about is what's your big picture? What's your goal going into it? For me, my goal was that I wanted to work for the Department of Defense or some way, shape, or form for the military. I've achieved my goal, and I'm working on satellites while doing that, which is the other part of that. How am I getting there? Have you put yourself in a place to succeed? And are you working on your soft skills? Because once you go into grad school, you're expected at some level to either lead research or lead a team. So are you working on your soft skills, like your communication, your emotional intelligence? Are you seeking feedback to get better at what you're doing? And then, you know, break it down. Think about what you're doing right now every day. Did it bring you closer to your goal? So in other words, are you effectively managing yourself? And this goes, yes, this is themed towards graduate school, but you can even do this as an undergrad right now. I mean, you've got a awesome opportunity to work on these soft skills right now and work towards being an even better manager of yourself and of other people. All right, so now I get to be the old fart. I did we got over the business, now I get to be the old fart. So before any of you were around, there were the Rocket Girls. And the Rocket Girls were special at Alabama because the Rocket Girls was a team made up entirely of girls launching rockets. There was no rocket program prior to the academic year 2010, 2011. They came along, talked to Dr. Baker, said, hey, we want to go do this. And he said, great, I'll do it. I'll help you out. So for 3 years, they placed in the top 10 of the NASA student launch teams. And for 3 years, they were a team. After that, they fell off in some numbers, added some guys. They became the Yellowhammer Club. They didn't really do anything that year. The next year, they were a club and a senior design team, and that was when I got involved with helping out with the senior design team. That was, the rocket was very affectionately named the Lawn Dart for good reason. So anyways, and then along came me and my old butt, and 2015, 2016, our senior year, we had a top 10 finish at NASA Student Launch. That was what you guys, I think, know as Aries 1 now. And yes, Yellowhammer was still, the club was still called Yellowhammer. That was when Brett and Carson came along, and I think Chase, you were coming along as well. And then the next year it became Alabama Rocketry Association. So, all right, I've done my old fart bit. Now let me see. Does anyone, or do we want to wait until after Chase goes before we have any questions, or how do you want to structure that, Jane?
How about if anyone has questions specifically for you, they can ask them. Otherwise, we can wait till the end and ask both you guys some questions.
Cool.
You should make a
Does anyone have questions specifically for Chris?
Crickets. All right.
All right, we can go ahead to Chase, and then we'll come back and ask both you guys some questions.
All right. All right, guys. Yeah, so pretty wide audience here. So my first slide is going to be like a little about me. Then I'm going to talk about some of the questions that I asked myself when I was trying to decide if grad school was right for me or kind of what my next career option should be. So for those who don't know me, my name is Chase Stroudman. I graduated in 2019 with my BS in mechanical engineering from UA. And then I moved on to Purdue University to do my master's. Also, just on my cover slide here, my phone number's on there, email. So if you have any questions that you want to ask me more in depth or whatever, I'm pretty accessible. So feel free to give me a call or shoot me an email. I'll get back as fast as I can. Yeah, so kind of my career path. So in summer 2017, I had my first internship. I started at UA in 2015, again, studying mechanical engineering. Then I had another internship in summer 2018 with SpaceX. And then after I graduated from UA in May 2019, I went back to Maxar Technologies, worked full-time for 8 months, and then started my master's in January of this year. I was always like pretty focused as an undergrad and getting hands-on experience. I found out that was like the best way that I learned personally. So I tried to always have like a hands-on approach to problem solving and also opportunities I was interested in. So getting internship experience and club experience through the Rocket team at Bama was huge for me, both in my career and just my actual knowledge base. So what kind of the reason that I chose to go to grad school. All my internships were kind of geared towards structural design, just kind of like the way the cookie fell, I guess. I still like design. I would still ultimately like to do design, but I knew deep down I really wanted a career in rocket propulsion. So I kind of felt like my career was trending in a direction that was opposite of that. And especially working full time, I entered as a mechanical design engineer. So I was working on flight parts, moving assemblies for robotic arms that are commissioned for space missions. And I kind of got roped into, I did design, like actual design for like maybe 2 or 3 months. And then because of my testing background, they needed an extra person essentially on the mechanical testing team. So I offered to help out, and that basically became what was my full-time job. And I was doing nothing propulsion related. The company I was at was doing nothing propulsion related. So I felt like grad school was a good step, I guess, to force my career in that direction. So that's one of the big draws for me personally. So yeah, the first thing I think that everyone should ask themselves if they're considering grad school is picture your dream career, and will grad school or any post-undergrad school in general benefit that? And kind of going off on that, I realize we probably have some freshmen here too that probably have nowhere near any of these steps right now, and that's perfectly fine. But yeah, I'd say by junior year, I kind of knew what I wanted to do. Again, rocket propulsion. So I kind of started to think, would graduate school benefit me? Do I want to do it right after undergrad? Do I want to work a little bit first? Is this something I want to work for 10 years and then go back and do? Those are all important questions, I think. Going on to the actual school and selecting a school, I would really encourage researching like technical papers and labs at all schools that you're considering. If you look at recent technical papers, you'll be able to see kind of what universities are actively doing work in the fields that you picture yourself working in or that you are interested in. And then schools' labs have a big range of work that they do. You'll do a lot of theoretical work. I tend to think that, theoretical stuff is super important. And it kind of ties in with hands-on experience a lot of the times. Again, like everything is first principles in engineering. If you understand the fundamentals, you can kind of apply that to any problem. There are also quite a bit of computational focused laboratories. Think more like on a computer, like running simulations. A lot of CFD work is done in a computational setting like that. And then some schools are just purely hands-on. If you're going to test frequently and test a lot, you're going to be a lot more hands-on with your stuff. And when I get to a later slide, I want to just talk about what I do. I definitely, again, fall in the hands-on role. And then again, if you're paying for grad school, you probably did something wrong in the process. You definitely, there's enough of a demand, I feel like, for grad students through various universities, fellowships like Chris was talking about, teaching assistantships, research assistantships, advisor sponsoring, stuff like that. I don't know like our stat at Purdue specifically, but a lot, like the vast majority of graduate students have some sort of funding or financial assistance. So there's a lot of ways you can pursue that. Chris probably did a better job of talking about that than I will, being a smart fellow himself. And then another thing to consider in terms of what degree is right for you. Do you want to get a master's? Do you want to get a PhD? Do you want to do a PhD and then a postdoc? And so questions to ask if you kind of find yourself in that situation. I think generally, in my experience, there's a little bit more funding opportunities for PhD candidates. So if you are struggling to get funding and you are kind of floating around with doing a PhD, that might be the option for you. And then I think the second bullet point here is probably the most important. What career do I want? And people that are currently working in this career, what kind of degree do they have? Is a master's even essential? Is any grad school essential? Like, because if it's not, you can absolutely go right into the field and work and learn a ton on the job. That's what a ton of people do, and there's nothing wrong with that. And then there's some fields where it seems like everyone has a master's. And when I was looking at rocket propulsion design, pretty much everybody that I had interacted with in my internships that did those type of roles, they all had some sort of advanced degree. And definitely some bachelor students as well. But yeah, so it just made sense for me in terms of what my career goals are. And if that doesn't line up with what your career goals are, it's perfectly fine. So a little bit about my situation at Purdue. So there's two types of research paths at Purdue for MS students. You can do a thesis-based master's program, which that has like, I believe 21 hours of class credit plus 9 hours of research credit, which that's not like 9 hours like you would think. That's like 3 research classes that you take during 3 semesters. And it's not even a class. You'll just live at the lab basically, and you'll come up with an experiment, design the experiment, determine what you want to test. Typically, either a professor receives a grant for a project from a company or a lab that is trying to develop something, and then if you get hired by that professor, they will act as your advisor. You'll be a graduate research assistant, and you'll perform that research. And sometimes you turn that into your thesis. Also, in some instances, at least here at Purdue, there have been students that have approached professors with ideas, and the professor will have some funding for them to pursue that, and they'll turn that into a thesis. You can also do a non-thesis masters, which is purely coursework based in terms of graduation. So I think at Purdue, it's like 28 hours. It's a couple additional classes from which you would take as a non-thesis student. And as a non-thesis master's at Purdue, you can still get lab experience. You probably won't get paid for that lab experience, but I mean, experience is key, as we all know. So me personally, I have a graduate research assistantship, which means I have an advisor at the lab that pays my tuition and also pays me a salary stipend on top of that. In exchange, I work on a project for that professor. So the lab I work at, which is Zucro Labs at Purdue, is pretty unique in the sense that we probably have 70% of our projects come in from companies approaching people directly. So it's not even like a grant-based process. They'll like come to our director of the lab, who's not even a professor, and be like, okay, we're this company, we want to test this engine. Here's our propellants, build a facility, we'll give you whatever money, basically, we think is reasonable to get your facility capable to handle this. So that's the first way. And then secondly, I'd say like the other 30% are the traditional, like professors get grants through Air Force Research Lab or the DoD for different development. And then they'll test that stuff. So I work on the company side. I worked on an RCS development project for Blue Origin that is part of that 70% company base that I spoke about before. So some of the things that I've currently done. So basically, this is an overhead shot of Zucrow Labs. It's a pretty big facility. It's also off campus, like by Purdue owns an airport, and it's like right by there. So there's like 7 or 8 different buildings in this picture here. So the stand that I lead personally is that little red circle there. It is legitimately a shipping container that we acquired in like 2004 that has been built up for a variety of projects in the past. And then those whole buildings in that section there, that's the high pressure lab. So that's where we do all the big testing for higher thrust engines and both gaseous and liquid propellants. So yeah, my like kind of day to day is I do a lot of build up work. I build fluids panels, design fluid panels, design and build data systems, stuff that I never thought I would do. I literally hate electricity. I hate working with electrical components, but here I am. Also, there's a fair bit of like actually being on LabVIEW, like running auto sequences, firing the thruster, which is obviously super exciting. And I started like just as a understudy of the current kid that was leading this project. He graduated in May, and I was installed as lead for the project after that. So I've been kind of leading a group of 3 people to build up this whole facility for the past couple of months. So we've been running stuff in that little red circle a lot, but we've also been doing a lot of build up on a separate stand, which I'll show you some pictures of in a second. And just some last things, threw some links in there for some more documents about Zucrow Labs if you're interested in learning more about it. One is just the general website, and the other one's like an annual report where they talk about like some current projects that are going on. Yeah, so this is kind of what I'm currently working on. So that's a big vacuum chamber there in the far left picture. And basically, we are building up fluids panels to take 2 separate propellants, a fuel and an oxidizer. Can't really speak about what they are, but I build up fluids panels for that. That's kind of what I'm currently doing. So that top right picture there is the fuel panel that I built and designed. And then the middle picture there is a nitrogen panel for all of our purges, propellant conditioning, which means like we can flow some LN2 to cool off propellants. We can also flow some heated water to warm up propellants because the company that we're working with is interested in testing them at different temperatures at vacuum. And then also I mentioned some data system stuff that I do as well. So like bottom right, a lot of electrical buildup, stuff like that. It's kind of all I really have. Kind of just wanted to open it up for more questions. Because I feel like you guys probably want to ask that the most. So I will mute myself and let people ask questions.
All right, yeah, so does anyone have questions? I definitely encourage you guys to ask, especially if you're not sure, what you want to do. You're not sure if you'd be interested in a post-grad degree. This is a great time for you to ask.
There are no stupid questions, by the way.
Also, I'll just start but if you guys are really going to make me ask all the questions, I think we might devolve into some weird questions. So why don't you guys, Liam and I will go ahead and start. Liam, you want to ask one?
All right, I have a question. Chris and Chase, I'm interested in grad school. What skills can I be developing now to make me a better graduate student in the future?
Chase, you want to start or?
Sure. So I think one thing that is pretty critical is kind of developing a personal work ethic kind of in everything you do, especially for what you are interested in for your career, which is hopefully why you're going to grad school. And then secondly to that, I think any hands-on experience on a team is huge, and leadership on that team is also equally important. Because like Chris was saying earlier, in grad school, you'll definitely be expected to take over the lead on projects. Sometimes when you literally have no idea it's even coming. I worked my project for literally like 3 months, and then I was put in charge of it, and I completely did not feel prepared in terms of like technical stuff. But like my basis in undergrad, like working in a team environment, definitely helped me handle some of that. So I think that's one of the most important things.
Yeah, I can definitely second that. Being a self-starter is a great quality to have. Some of you may not get the opportunity to have leadership on teams, but there are other things that you can do. You can get practice providing technical presentations, because that's going to be a huge part of what you do. And then the other thing that I wanted to hit on that, Chase, you made a good point of that I didn't even think about. You were talking about how research comes to your advisor and they have funding, right? And Zucro, you guys get 70%, get out of here, of commercial projects. But part of what you're going to have to do in grad school is you're going to have to provide support to your advisor for research proposals where they actually go out and get money. So developing those technical writing skills now, or at least your technical presentation on, hey, this is a real benefit and here's why we need X amount of money, is a good thing to practice. And I think you guys are going to get a lot of practice with that through ARES. ARA, right? I'm old, sorry.
Thank you. I'll work on those skills before I get to grad school.
Awesome. Thank you guys. So then I have a question. So I just want you guys, like in an ideal world, what is your dream job, and how do you think, I know Chase, you talked about rocket propulsion, but I'm just curious, where do you guys want to end up? What is like your dream position in a job?
All right, I'll take this one, or I'll start off first since I made Chase go last time. For me, my dream or my career goal is being the project manager on a team putting U.S. astronauts on Mars. That's the end professional goal for me. After that, I can retire, teach. I don't care, but that would be the dream goal, and that's what I'm working towards right now.
Yeah, I've always been like a huge Star Wars fan, like ever since I was a little kid, and that's kind of what got me interested in space originally. I was always interested in the exploration aspect of it. So I think my ideal job would be design and test of propulsion systems for interplanetary travel, not just Mars. Probably I'd like to go to Europa. I want us to go everywhere, right? I think everyone does. And that's kind of what gets me excited. It's kind of like literally being able to go anywhere, like at least in the solar system, if not more. So yeah, I'd say like any job where I'm working on propulsion systems for a mission like that's going to carry something meaningful, even if it's not people. That's kind of what my dream job would be.
Awesome. Thanks, guys. Anyone think of any questions yet?
I have a question, but it's kind of dumb.
No, it's not.
Okay, so I'm like a freshman, so like I have no idea about anything yet. But so is grad school and stuff after that, do you only do that really if you want like a job that does more research? Or what? Like
I can take that. Not necessarily. So for me, my GPA was crap coming out of my bachelor's, which partially affected my decision. I had a job offer from OneWeb, which I'm kind of glad I didn't take now that they went into bankruptcy. Or I could stay on with my advisor, Dr. O'Neill, and his goal was, or what made me reject OneWeb and go with him was, he treats dissertations as a business opportunity. So if you have what I'm working on right now, I'm working on for the Navy, but on the commercial side, I could turn it into a contract or a business opportunity. Then what I'm working on right now is on-demand launch via airborne platforms for satellites using the F-35. But so yes and no. Yes, you can use it to go get research or to do more research if that's what you're interested in. But it doesn't have to be. You can use it as a opportunity for a business proposal. You can use it as, maybe the jobs that you were offered you didn't really like, and you've got an opportunity to like Chase to go to Zucro Labs and work on some really cool propulsion testing stands, right? Where you can go get hands-on experience. So it depends on what you want to do, but you can do a lot with it. So yes and no.
Okay.
Yeah, to follow that up too, I like when I was looking at grad schools, like I definitely wanted to go somewhere where I would essentially be working as if I was working in a full-time role, right? And like you can definitely go both ways. Like if you want to do research, you can go into a research career out of bachelor's, if that's something you want to do. You can also just go into industry after bachelor's as well. And you can do the same thing with a post-grad degree. Just to give you an idea too, like the engineers that I work with that sponsor my project, literally their job at their company is doing exactly this. So like I'm basically working as an engineer. It's not even like you're necessarily doing research per se. And that being said, like I think research kind of gets like a misnomer sometimes where like people think, oh, like if you do a ton of research in your PhD, like you're not going to be valuable in like an industry setting. I think that's like completely not true. Like you'll learn like just through testing things and computationally testing things, you'll learn techniques that you would do on the job. Even like something that sticks out to me is like, the data system stuff. I never thought I'd be working with like different types of thermocouples, a ton of different pressure transducers, understanding how the instrumentation works and like where to put it on like a research rig. But that stuff's like exactly what you would be doing if you were like testing engines for NASA or SpaceX or what have you. So I think like, I definitely don't think it's just exclusive to research. I think you can definitely get whatever experience you want and go into whatever sector you want, if that makes sense.
Okay, thank you.
I just wanted to add something in on that. So I work part-time at Aerojet Rocketdyne right now. And I've interned there the last 2 summers, but I'm working part-time for them. And, I agree with Chase and Chris, so this kind of might not be super important. But, there's tons of people there in all the jobs from like, quote-unquote low-level worker to, director of engineering who have, master's and PhD degrees. And, Aerojet, I will say it's one company that does not do a ton of research. They are a lot more focused on how do we make products more from a manufacturing standpoint, just to design it, push it out, and put it in use. So I completely agree with Chase and Chris.
Awesome, thank you.
All right, we got some questions in the chat. Do you guys think grad school is worth it? Also, hashtag go Hoosiers. Oh no.
Go Hoosiers.
Boo. Yes, grad school is definitely worth it. I'm given to work doing what is the line I have to give? I'm doing integration on the F-35 out at NACWD for China Lake. So and I get to work with satellites, and we'll leave it at that. So yes, grad school is worth it because that opened the door for me to go do something that I really enjoy. And if I hadn't, I'd be sitting somewhere probably without a job because I would have gone with OneWeb, who went bankrupt. So yes.
All right, boiler up. hate that go who's there, but whatever. Yeah, for me, it was definitely worth it. Also, I didn't mention this in the presentation, but when I was at UA, I was part of the STEM Path to MBA program. So I had a +1 year to get my MBA. I actually decided to drop out of the program my senior year because I kind of realized, like, through some internship experience, that I definitely wanted a technical career, at least first off. So yeah, I think grad school was a great choice for me personally. And again, I think like I was saying before, the original reason I went, I kind of felt my career was trending into a direction where I didn't exactly want it to go. Wanted to do more propulsion stuff, and I was doing more structural design. And yeah, it literally, like, I go to work and test rocket engines. So it's like, that's like perfectly in line with what I want to do. Like, I hope my career is the same way as this, honestly. So yeah, it was definitely worth it for me.
Awesome. And then the second question, this is actually a great one because Chase did an undergrad in mechanical and Chris did an undergrad in aerospace. So we have a question: if I want to major in aerospace but keep the door open, would you recommend getting an undergrad in mechanical with a master's in aerospace, or the other way around, or really does that matter? What do you guys think?
I can start off with this one. So I think, like, I'm pretty passionate about this. So I think, like, there's way too much emphasis put on, like, what type of engineering that you're studying. An engineering degree is a problem-solving degree. Like, no matter what type of engineering you decide to study, bachelor's and master's, it can be applied to literally any industry. Like, when I was working full-time, I had a bachelor's in mechanical, but I was working with electrical engineers. I was working with aerospace engineers. I was working with materials engineers every day. It's one cohesive team, and everyone's like trying to solve problems together. Someone might have a more expertise in a given area, but I think like, it seems like a huge deal at the time, obviously, like, you know, deciding what you want to major in college. But I promise you, like, it's almost more important to know what industry you want to work in. And then you can kind of tailor whatever you're majoring to take some elective classes maybe in areas that apply to that industry.
Yeah, I wholeheartedly agree with Chase on that one. I wouldn't worry so much about which one that you need to major in. It's more about your breadth of knowledge and what you go and work on, right? Like, I mean, even in aerospace, right, there's specialization. If I had gone and done DBF, design, build, fly, my senior year, okay, well, you know, I'm saying, hey, I want to work on aircraft to whoever I'm applying to for a job, right? But I knew I wanted to work on rockets. We got a rocket senior design team together. You know, you get the gist. But it's more important on what you do, including those electives. And I mean, I have my best man at my wedding, right? He went and he was a Bachelor of Science in geology, and now he's coming back for his PhD in electrical engineering. Like, you know, he came back for the engineering degree because of, you know, what he's trying to do. Not so much the electrical part of it, but the engineering part of it. Because he took some GIS and some other courses and electives that ended up being applicable out to out to China Lake. And so lo and behold, he's doing electricals work, and he's doing electricals work better than some of the electricals out there. So he wants to get paid for it now. So he's coming back. So like Chase said, it's not really a big deal which one you choose. It's more about where you want to go and tailoring your experience to that, whether that's electives or some experience with ARES, or, you know, if you want to do aircraft design, build, fly, or what have you.
Yeah, the VP of vehicle engineering at SpaceX studied economics as an undergrad, and just did the Formula Car team because he just liked cars. And then he went back and did a master's in mechanical. So yeah, I don't think major is a huge deal.
All right, well, we have another question.
So I have a pretty interesting question. So what were your roles in ARA/ARES, And how well do you think ARA/Aries prepared you to take the next step into, I guess for you guys' case, it's grad school. But how well do you think it prepared you outside of the classroom?
Chase, you want to take that one first, or you want me to go?
Yeah, I can go first if you want to. So you asked about roles first, right? So I was project manager my junior and senior year on Aries. So my junior year, we went out to Spaceport America, and it was the second year we went competed in the solids category. So I think that would be what Project Demos is doing now. And then my senior year, we started baselining a liquid rocket engine for the Base 11 Space Challenge. But the important part was laying some of the groundwork and conceptualization for a suborbital university rocket launch. So I think it was instrumental, honestly, not just from a technical background, but also from working on a team, having leadership and personal accountability for tasks that you're working on. Also hands-on experience. I know I've said that like a million times today, but like you'd be shocked by how many people that like I started with when I worked full-time, even before grad school for a little bit. There were so many new hires, and sometimes people that are even there for a couple of years that just like sometimes they just don't see how things are manufactured, and they'll design something that cannot be manufactured. I think like by working on a student team where you're doing all the manufacturing yourself, it really teaches you that in basically ways that no other way can. That's something you're not going to learn in a classroom. That's just something that you're going to learn by designing, building stuff yourself. So yeah, I think it prepared me really well. I didn't feel overwhelmed in the real world, and I don't feel overwhelmed most of the time in grad school either.
Yeah, I'd forgotten you had done so much. So Aries for me, going back, you asked about roles. So my role in Aries, or Aries 1, I guess, was the rocket design. So we had a payload portion, and we had a rocket design, and then we had a team lead above that, and I was the rocket lead. So I led a team, and I personally struggle with I give advice, and I personally invest myself in that advice I've given. And so something I've learned over the years, and that I learned through that team, was to not be so invested in that advice, because I want to see people do well, and sometimes I kind of attach myself a little too much to it. So it was interesting leading the team, and it was a democracy. So sometimes we're talking about how we want to design the rocket a certain way, and I disagree, but it didn't matter because the team had made a decision, right? And so learning to have that experience and realize that no, it doesn't really matter. It's where we're going to put the bulkhead plate. Like it'll be fine. We'll figure it out in the end. It's not going to blow up the rocket. Figuring that out, and kind of learning how when to, or learning to pick my battles. There we go. It was really important, especially now in the environment that I'm in, where there's a lot of communication. And in order to get anything done on a government facility, as I'm sure Chase and Liam and Jane can attest, sometimes you walk up to somebody and they say, "Oh, I don't know if we can talk to you about that, because we're not sure if you have the right clearance." And really what that means is they don't want to talk to you. So learning to learning good communication skills was instrumental, and my technical skills as well. That last year, like I did some research for Dr. O'Neill that kind of honestly led into what I'm doing now with my dissertation. I did 6 degree of freedom model for the rocket, because I thought it was going to be this brand spanking new thing, and behold, March, after we've already launched the dang rocket, I still haven't finished the research on, how to make this thing work. And I'm getting loop-de-loops on my simulation of the rocket, but clearly that's not what happened to the rocket, right? So learning to kind of harping on Chase's point, learning to manage myself and get to that point where making accurate time estimates and communicating those was important, to say the least.
All right, I have another question, unless anyone else has one. And you're also more than welcome to send them in the chat if you don't want to or can't speak on the microphone. So this, just going a little bit off engineering for a little bit, if you're ever feeling like overwhelmed or just tired of staring at, your books, your computer, whatever, what kinds of things do you guys like to do to unwind or de-stress?
I'll start this one. So I have two jobs. I work for the Department of Defense, and I'm also a college basketball referee. I officiate at the Division II level in the Southern Intercollegiate Athletic Conference. So unwinding, I guess, is having a beer and watching film of myself run up and down the court and evaluating myself on, okay, how do I look? Yep, okay, did I see the play correctly? And, referee stuff. I don't really have good hobbies. I have dogs. We go outside. We play frisbee so we can actually get outside. But that's about it. I'm kind of boring. I'm sorry.
So I have a ton of hobbies. I feel like it's almost too much, honestly. But I like anything outside. Really into backpacking. For those that aren't familiar, just taking all your camping gear with you on a backpack for a weekend or however long you want to go sometimes. I also really like running. If anybody's on Strava that's also a runner, feel free to follow me. Yeah, I like distance running a lot. I like reading, mainly nonfiction, non-class related. I think that's important too. And then I binge watch shows on Netflix. I like discovering new music. There's a couple like music blogs that I follow pretty closely. Big into record collecting as well. Yeah, I'd say that's my big things. Oh, and coffee. How could I forget?
Attaboy. Hey, I've got a quick question for you, Chase, actually. Have you read Gene Kranz's Failure is Not an Option yet, by the way?
I have not. But actually, Zucro started a book club. I believe that's on the list.
Yeah, it's fantastic. You need to read. So for those who don't know, Gene Kranz was the mission controller for Apollo 13. So when you're watching the movie, he's the guy with the white vest. But yeah.
Have you read Skunk Works? That's also on my list.
Yes. Yeah, it's a good read as well.
Yeah, I really want to read that too. Right now I'm reading Ignition. It's like a pretty funny history of liquid propellants. It gets pretty in depth. Like it's a very slow read. I've had to Google like so much stuff to figure out what's going on, but it's pretty cool. It's basically like this. It's the way I can describe it. It's like all these like 60s, 70s guys that like get together and like they basically just like go to someone's like garage at this point, like test cell, I guess you could say, and they just literally try new propellants. It's like really scary. Like there's like one section where they like talk about new space a little bit, and they're like walking in a hangar, and some guy's like, hey, like that girl over there has like a lot of tattoos and like dyed hair, and the guy who's taking them on the tour is like, you better be nice, she's probably doing your thermal analysis. It's pretty cool. But yeah, I would totally recommend that book to anybody who's interested. It's a pretty good one.
Do you know who is it by? Do you know?
Let me grab it. It's in my living room.
John Tibbetts loves that book. I remember he was talking about when he ordered it.
Awesome. Yeah, I'll have to go ahead and
It's
order
by
that. That's awesome.
John D. Clark. It's called Ignition: An Informal History of Liquid Propellants. Really
That's
cool.
pretty cool.
Yeah.
All right. Well, if nobody has any more questions, do you guys just have any closing remarks you want to leave us in? Any last thoughts? And then we'll go ahead and wrap it up.
You're up, Chase.
Yeah. I guess like don't like stress out about the decision to like go to grad school or not. It's not worth it. Just like sit down, like think about it every once in a while if it's something you're considering, and just ask yourself some questions. That's really all there is to it. And yeah, I think like being on this team in general will prepare you for whatever career you want to have. You'll get great hands-on experience, great experience working with other people, and also great leadership experience, whether you're a team lead or not. I think like personal accountability is really important throughout life, not just your career. And I think that's something you really are already taking steps towards by being on this team. So yeah, again, I'm sure Jane will share the PowerPoints with y'all, but feel free to shoot me an email or phone call or whatever, and I'd be happy to talk with you if you have more questions down the line.
Yeah, same as Chase. If you have questions about opportunities at University of Alabama for graduate school, feel free to reach out. Jane, feel free to share my email and phone number with them. I'm also on the Slack. I think Chase is on the Slack as well, so which you guys should be on. And then just in closing, going to graduate school is about providing an opportunity for yourself for what you want to do. So if you really want to go work on rocket engines and test rocket engines, you may have an opportunity through industry, or if you're not provided that opportunity, you may be able to get that opportunity going up to Purdue and Zucro Labs and go work with Chase for a little bit. But have the big picture in mind of what you want to do and, work towards that goal. Because I think all of you are taking the right steps. You guys decided that you want to work with rockets. You're with a really good program or a really good group here, and keep it up. We'll see what happens. Hopefully I get to work with some of you guys in the future.
Thank you guys so much. Yes, I will send out the PowerPoints. I'll send out their information to you guys. I'll send it in Slack. And then Liam has some closing remarks about a program at Alabama that you guys should all consider.
So there was one more program that we wanted to talk about. Neither Chase nor Chris participate in, but Jane and I both participate in. It's called the Accelerated Masters Program. It's AMP for short. The whole idea with AMP is as an undergrad, you were able to take up to a certain amount of hours as dual credit hours, and you can make your master's shorter than 2 years or however long it's going to last you. So I've been lucky enough. I only had 4 extra classes after my undergrad for my master's. I was able to take a bunch of grad classes as an undergrad. So I only had 1 extra year for my master's, and I get to do it the whole time, part-time while working, which is nice. So if you're interested, you can reach out to me or Jane for more questions about it. I'm a huge grad school proponent, and I can talk to you for hours about grad school. But that's just another program we wanted to mention out there. So if you have any questions, feel free to reach out or ask them now, or either way.